All right, this is 10.6. This is the 6th section in chapter 10, segment relationships in circles. So we're going to be talking about segments specifically. Remember, a segment is a line that has two endpoints. So let's jump right in. We're going to start off with a theorem. It's the segments of chords theorem. So a chord is a segment in a circle where the two endpoints are on the edges of the circle. So C, D, and A, B here. So this is talking about intersecting chords. That's what this theorem is about. So if two chords intersect inside a circle, so here you can see they're intersecting at point E. Now when they intersect, they split into smaller pieces. Not necessarily equal pieces, but they split into smaller pieces. I have AE, BE, CE, and DE. So if two chords intersect inside a circle, then the product, where do we get products? We get products from multiplication. Then the product of the two smaller segments created from one chord is equal to the product of the two segments of the other chord. So keep in mind, so we're working with the same, so each chord gets broken up into pieces. We're working with the same pieces, all right? So product equals a product, so multiplication equals multiplication. So AB is split up to AE and BE. CD is split up into CE and DE. So those products are what are going to give us that equality. So AE times BE is going to equal CE times DE. So yellow times yellow equals pink times pink. So let's kind of use that theorem to solve. So here I want to solve for x. So it's going to be 2 times x plus 3 is equal to 4 times 3. So x plus 1 times 2 is equal to 4 times 3. So distribute that. You're going to get 2x plus 2 equals 12. 2x equals 10. So in this case, x equals 5. Not so bad. Definitely going to flex our algebra skills in this section. All right, this next one has a lot of x's, but don't be alarmed, we'll be fine. So here I want x times x plus 4 and x plus 2 times x plus 1. So we are going to have to FOIL here. So we want to make sure that we're going to be careful when we're FOILing. So I have x times x plus 4 is x plus 2 times x plus 1. So if I FOIL that, x times x is x squared, x times 4 is 4x equals x times x is x squared, 2 times x is 2x, x times 1 is just x, and then 2 times 1 is 2. So don't be alarmed by the squareds because they're actually going to go away. So we have x squared plus 4x equals, if I combine like terms, x squared plus 3x plus 2. So if I was to subtract x squared from both sides, there's 1 on each side, so they're actually just going to cancel out, which is nice. So that gives me 4x equals 3x plus 2. I can subtract 3x from both sides, and x equals 2. So it's a little bit more algebra, but definitely doable. Now, x is 2. This question asks to find ML and JK. So, if x is 2, ML is 4, x plus 2, so 2 plus 2 is 4, and x plus 1 is 3. So ML is going to be 7. And then JK, x plus 4 is going to be 6, plus 2 is 8. So JK is going to be 8. So always keep in mind what the question is actually asking you to do. All right, so these next few theorems are talking about tangent segments, secant segments, and external segments. So we're going to make sure we know what those pieces are. So a tangent segment, again, it is a segment, so it has endpoints, but one of those endpoints is going to be a point of tangency. A secant segment, remember secants are lines that go through a circle, so the secant segment is kind of cutting out there. And then your external segment is if you had a secant segment and kind of extended it out. So let's kind of put that into words. So a tangent segment is a segment that is tangent to a circle, at one endpoint. So if this was the tangent segment, so I'm going to highlight that in yellow, this is the tangent segment. The secant segment is a segment that, now this is important, a segment that crosses through a circle and has one endpoint outside the circle. Wasn't sure how I wanted to phrase that. So in this case, this is a little bit different. The secant segment is this whole piece. So the secant segment is the whole piece. So it's the only difference between a secant is it actually kind of doesn't go out that other side. So it has one endpoint on it, one endpoint outside of it. And then finally we have the external segment, which is the piece of a secant segment that is outside the circle. I don't have another highlighter color, so I'm going to do that one in red. So this is the part that is the external segment. So the tangent segment is here, the secant segment's this whole thing, and the external segment is just PQ right there. So yeah, let me actually put those names there too. So the tangent segment, that's PS, the secant segment is PR, and the external segment is PQ. So there is a lot of vocab in this next one, just kind of, it's a long theorem, pull through it. So, segments of secant theorem. Say that 5 times fast. So, this one is, so if I have two that are going through it. So I have two secant segments, two external segments. So if two secant segments share an endpoint outside the circle. So here I have EB and ED, they both meet at E outside the circle. Then the product, again product, so we're multiplying, then the product of the whole secant segment and its external part, or its external piece, is equal to the product of the other whole segment and its external piece. So it's kind of similar to that first theorem we did, so the product of the two pieces. The only difference is now I'm taking the product of this whole thing and the piece outside, and it's equal to the whole thing and the outside piece. So here, EB times EA, that's going to equal ED times EC. So let's try an example of that. So that's on the next page, but I don't want to start a new section quite yet. So here, I want to find X. So it's the product of RQ times RP, RQ times RP, and RT times RS. So I'm going to write that out first. So RQ times RP is equal to RT times RS. So what is the length of RQ? The whole thing, if this inside is part is 11 and the outside is 9, that's going to be 20. So 20 times RP is 9. Now we want to be careful. What is RT? It's the two pieces together. So 10 and X together are 10 plus X. And then RS is 10. So let me zoom in and we'll kind of work through this. So 20 times 9 is 180. And here I want to kind of distribute that 10. So 10 times 10 is 100. 10 times X is 10X. Subtract 100 from both sides. I get 80 is 10X. So X is 8. And that's how we use that theorem. So make sure you keep all of these formulas on hand. It'll especially help you with your homework. And all right, now watch the 10.6 part 2 video.